Hi everyone, welcome to array series. So today we are going to see a different problem which says that we are given a sorted array which consists of 0 and 1 and you have to find the index of the first one in that sorted array. So basically you are provided with a binary array which consists of either zeros and ones which are in sorted manner, and you have to find you have to return that index where that first one is present. What the problem further says that there could be a possibility where all zeros or all ones are present. So if there is such case where there is no one present, then you have to return -1. But if all ones are present, then of course simply you can return 0, which is the first index. So let's look at the examples. So if you see here, there is the index 4 which consists of the first one. So what is the output? Output is 4. Similarly, in the example 2, if you see, there is no 0 and the first index itself consists of 1. So what we have written? We have written 0. Now if you see example 3, there is no 1 at all. So what is the output? Output is -1, which the question also says. So one thing that you must give importance in this question is that the array is a sorted array here. That means all zeros are there initially and then ones are there. And what we are going to see in this problem is we will be seeing different approaches to solve this problem along with their code and with their time complexity and the space complexity of all the approaches that we are going to see today. So whenever you get such kind of questions in the interview, what you should do is you should always start with the very basic approach that comes to your mind. Of course, for some order n problem, you should not be giving some problem of n cube or n4 something, but if you feel that this problem might be a feasible solution of this problem, then you should definitely start from the basic solution. So if I see the one of the very basic approach, of course I see that this problem could be solved if I just iterate the complete array or I run a loop over the complete array. So I should not give any approach which is like n cube or n4 or something. So what approach I'm going to give for this particular question is I would run a loop completely over the array, and I will check, for example, if my example is 0 0 0 1 1 1, what I would do is I would run the loop over the array and I would check if that element is 1, if that element is 1, if that element is 1, if that element is 1. Yes, this element is 1. Then what I would do, I would just simply return the array. I would simply return the index of that element, and if I don't get any element at all which is 1, then I would simply return -1. So if you see that it's just run the loop. So let's see the code of it. I have assumed here that you don't know the size of the array, so you can find the size of the array using array.size. Now what I'm doing, I'm simply running a loop and I'm checking if that element at that particular index is 1. If it is 1, I'm returning the index I. Otherwise, what I'm returning, I'm returning -1, which says that no 1 in array, right? So if you see, time complexity of this approach is order n, and space complexity is order 1, because we are not using any extra space. But you see, this order n should not be the best approach to solve such kind of question, right? If the interviewer has asked you, that means there must be a better approach to solve this question, because this is the very basic approach, and even a third class student would do this question. So what I'm going to do with this problem is just think of a different solution. And what I could think is, since the array is already sorted and you have to search something, so what could be better than binary search, right? So let's see if we could run binary search on this. So let's take a new example. Let's say you have 0 0 0 0 0, and then let's say you have 1 1 1 1 1 1 1 1. Okay? Now you have this big array. 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So this is array of 15 elements. So what is a mid? What is a mid? So mid is 15 by 2, which is 7. So what I would simply do, I will check the mid of that array and I would see if it is 1 or if it is 0. If it is 0, we know that we don't have to go to left, because why to go left when the array is already sorted, and you know that if an element is 0, all the elements before that element would be 0 only. So there are two possibilities now. If that element is 1, there could be two. If mid is 1, there could be two possibilities. Either the mid minus 1 would be 0, right? If the mid minus 1 is 0, that means this was the index you were searching for, right? So for the last few iterations, this was the element you were searching for. So if mid is 1 and mid minus 1 is 0, that means you have to return mid, right? But there could be other possibilities when it is like this. This is your mid, and all the elements after that mid and all the elements before that mid are all 1. Then in that case, you know that you don't have to see the right side. If you see here, if you come here, let's take this one. If you come here, then you know that this mid minus 1 is not 0. That means there are 1 before this element as well. So why to go right when you know that you have something before this also, and these are not needed because already 1 is there and this is not the first one. So don't go to the right side. So we have completely discarded the half of the array. Now again we will take mid for 0 plus 7 by 2, which is 3. Now again I came to here. So if you see, now it is 0. If it is 0, I know that left may I won't have anything because all elements are 0. So what I need to do, I would discard this part of the array and I would go for this part of the array. Again, if I do mid, it would be 4 plus 7 by 2, which is 11 by 2. 11 by 2 is 5. So if you see 5, now again mid is 1 and mid minus 1 is 0, right? Mid minus 1 is 0. That means this was the index I was searching for. So I would return my 5. I would return 5, right? So this is as simple as that. You already know that binary sets has time complexity log n. So we have definitely improved from order n, right? So I hope this is clear to you. Let's see the code for this approach as well. I have already written the code so that I don't end up wasting my time in writing the code while recording the video. It saves a lot of time. Let's dry run also. While running it, let's dry run it. Let's take some other example. 0 0 0 1 1 1. Let's see 0 0 0 here also. That is 0 1 2 3 4 5 6 7 8 9 10 11 12 13. So now you know that size of the array is what? Size of the array is 14. So we have called one index. We have called a different function, first index, which takes my starting index, which takes my end index, and of course it takes the base address of the array. Now I'm running the loop while my start is less than end. Of course your starting point should be less than the ending point. What we have done, we have checked start mid is equals to start plus end by 2, and if you see here, my mid is what? Mid is my 0 plus 13 by 2, which is 6, right? So I came at point 6. So ideally I know that this element is 0. That means I don't have to see anything before that element, right? So let's see code wise. So I've checked if array at mid is equals to 1 and if mid minus 1 is equals to 0, the condition that we discussed earlier. Also I have added one more condition here, that if mid is equals to 0, that means it is a starting index, which we talked about the example 3 in the beginning of the video, that if mid is equals to 0, that means all the elements are 1, right? So in that case I have to return mid. That means return that index. All the elements before that index are 0. So this is the index I was searching for. So return mid. But if array at mid is equals to 1, that means there is no 0 before it, there are 1 before it. Then you have to discard the right part of the array. That is what I have done. I have made my end is equals to mid minus 1. Now this part what it satisfies this problem. So it says make my start is equals to mid plus 1. So now what is my start? This is my start. Okay, so now my start is what? 7, end is what? 13. Again if I calculate mid, it would be 13 plus 7 20. 20 by 2 is 10. So I came here. Now again I will check. I will check because my starting point is less than ending point. If array at mid is equals to 1, yes. But is array at mid minus 1 is equals to 0? No. Is mid is equals to 0? No. I won't go for this condition. What I would do, I would make end is equals to mid minus 1. Discard this. Okay, discard this one, just take this one. Now if you take 7 plus 9, 7 plus 9 by 2, what would be the mid? 8. This is the mid. What I would do? Just discard this part as well. Now I would come to this part. Start is less than or equals to 20. Yes. What is the mid? This one. Array mid is equals to double is equals to 1. Yes. Mid minus 1 double is equals to 0. Yes. Return mid. So what I have written? I have written 7. Right? So what is the time complexity of this problem? I hope it is clear to you. Time complexity is order log n. Space complexity, we have not used any extra space. So time complexity is order log n. Space complexity is order 1. Now let's see one more variation of this problem. What if I tell you that it's an infinite array? Okay, so let's see. What I'm trying to say is this is the array. 0 0 0 0 0, then it is 1 1 1 1 1 1 1 1 1 and so on. Means you don't know the n, you don't know the size of the array. It's an infinite array. As many as 1 you can have, as many 0 you can have. Of course 0 would come before 1, but infinite array, I don't know the size. So what would you do in that case? How would you check? Because all those approaches, if you see, we have n with us, we had n with us, right? Here also we had n with us, here also we had n with us. But what if you don't have n? How would you do? So very simple. We would go with the binary search thing only. We would solve here also, we'll solve in the log n time. But what we would do is just check this, since this is a 0th index. So what is the approach here is, first of all, check for the first index, if that is 1 or not, right? If that is 1 or not, then check for second index, if it is 1 or not. Then check for 4, then check 8, then 16, then check 32, and then check 64, and up to 2 raised to the power. Just go for the 2 raised to the power, let's say x, because we don't know what would be the size of the array. Let's say at index somewhere like 35, let's say currently. So assume that this is your 32 index and this is your 64 index. It is somewhat like this. It is somewhat like this. So at 64 you know that it is 1, but you knew that at 32 it was not 1. So you know that somewhere between 32 and 64 it is 1, but you don't know exactly where. So if you see, you have skipped so many indexes here, you have skipped so many indices after that. So what you have done, you have just iterated on the cycle of 2. So 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to the power 5. And once you know that at current index it is 1, but at previous power of 2 it was 0. So what you have to do, you have to check only between these. So you have got the starting point, you have got the ending point. Between these you have to check, right? Between these you have to check. So what is the what time does it take? So if you see, you are only checking for the what you are doing, you are only checking for the you are skipping all the indexes, but you are only checking which are power of 2. So how many index you would be end up checking? You would be checking log n. And once you find those two indices, again you would be running binary search inside it. So again it would take order log n. So time complexity again would be log n only. Okay, so let's see with the code, and I hope it would make it clear for you guys. So we would just directly check at index 0, because of course if you multiply anything with 0 it won't return anything. So I'm just checking directly. If array at 0 double is equals to 1, then directly return 0. You have to return that index. Otherwise what I've done, I've made current index is 1. Okay, so I've checked if array at current index, if at that index if it is 0, then what you need to do, just store that index in some previous index. For example, let's take one example here. 0 0 0 0 0 0 0 0 0 0 and then 1 1 1 1 1. So assume this first index is at index 35, and let's suppose this is 64. Okay, of course there is some element after that, and let's assume this is 32 index, this is a 16, this is 8, this is 4, this is 2, this is 1, and let's say this is 0. Okay, so this is your array. So I have checked if array at 0 is equals to 1, no. Then what I've done, I've made my current index as 1, and I haven't stored anything in the previous index as of now. So I've checked if array at 1, which is current index, if it is 0, yes, what would I do? I would store this in this previous index and I would make it as 2. Then again I have checked if array at 2 double is equals to 0, which is true, what I would do, I would make it as 2 and I would make it as 4. Then is at 4 it is 1, no, I would make it as 8 and I would make it as 4. Then again if array at 8 is 0, yes, I would store 8 here and 16 here. Then again I would store 16 here and 32 here. Now again what I would do, 32 I will store here and I will store 64 here. But if now you would come back, is array at 64 double is equals to 0? No, it is not 0. So what you have got, you know that now the area where you need to search is this much, right, between 32 to 64. So you have got your previous index, you've got your current index. Previous index is 32, index is 64. Okay, and this is array, this is your index. So what time does this loop takes? It takes log n, because at the end you are only going to, no matter how big your array is, you would be covering only the log n indexes. Okay, I hope this much is clear to you in your algo classes, but it would only cover log n, and no matter how big that array could be, this would, in the worst case, like if it is like very big numbers are there, like your array is of very big power, that time only, in that case also it would be considered as constant only. So your time complexity would still be order log n. In space complexity we have not utilized any extra space. For the code for this function, it would remain same as this, right? First index, start and end, it would remain same, but this is just a different variation where you would not know the size of the array. So I hope that this also is clear to you. It was not that difficult. Yeah, thank you, bye.